If you like this video, subscribe the channel and press the bell icon to get notifications. These are some assumptions that are made for merchant circle diagram. Let's start with merchant circle diagram. This is tool, and this is workpiece. This is workpiece. This is workpiece. This is chip. Tool, workpiece, When tool moves in this direction, cutting takes place and chip is formed, and some forces are implied during the cutting. This is cutting force, FC. FC is the cutting force. This is thrust force, FT. FT is the cutting force. FC, cutting force, and FT, thrust force. And this is resultant R. R is the resultant force, and this force is shear force, Fs. Fs is the shear force, and this is normal to shear force. This is Ft, and this is NS, normal to shear force. And this is NS is the normal to shear force. Fs is shear force, NS is the normal to shear force. And this is friction force, and this is normal to friction force, F and N. F is friction force, N is normal to friction force, and this angle is phi. Phi is shear angle, and this angle is beta. Beta is friction angle. And one more angle, alpha. Alpha is rake angle. Let's make a free body diagram for cutting force and thrust force. This is cutting force, Fc, and this is thrust force, Ft, and this angle will be beta minus alpha. This angle is alpha, and this is beta, and this is 90 degree, means this angle is 90 minus beta, and this total angle is 90 degree, means 90 minus beta plus alpha will be 90 minus 90 plus beta minus alpha equal to beta minus alpha. This angle will be beta minus alpha. This is alpha and this is 90 minus beta, and this angle is beta minus alpha. This angle is beta minus alpha, and this is 90 degree. Sin beta minus alpha will be ft upon r. This is r, ft upon r. ft will be r sin beta minus alpha, and cos beta minus alpha will be fc upon r. fc will be r cos beta minus alpha. ft equal to r sin beta minus alpha and fc equal to r cos beta minus alpha. Let's make a free body diagram for shear force and normal to shear force. Shear force and normal to shear force. Fs and Ns, and this is resultant, and this angle will be phi plus beta minus alpha, as this angle is beta minus alpha and this is phi, means this angle will be phi plus beta minus alpha, and this angle is 90 degree. Cos phi plus beta minus alpha will be Fs upon r. Fs will be r cos phi plus beta minus alpha, and sin phi plus beta minus alpha will be Ns upon r. Ns will be r sin phi plus beta minus alpha. Let's make a free body diagram for friction force and normal to friction force. Friction force and normal to friction force. Friction force F, normal to friction force N, and this angle is friction angle, that is beta, and this is 90 degree, and this is resultant force R. Sin beta will be F upon R. F equal to R sin beta. F equal to R sin beta, and cos beta equal to N upon R. N equal to R cos beta. Now we have Fs equal to R cos beta minus alpha, Ft equal to R sin beta minus alpha, Fs equal to R cos phi plus beta minus alpha, Ns R sin phi plus beta minus alpha, Fs equal to R sin beta, n equal to r cos beta. Fs equal to r cos phi plus beta minus alpha. As we know, cos a plus b equal to cos a cos b minus sin a sin b. So let's assume a equal to phi and b equal to beta minus alpha, means r cos phi cos beta minus alpha minus r sin phi and sin beta minus alpha will be r cos beta minus alpha, r cos beta minus alpha and cos phi minus r sin beta minus alpha sin phi. This quantity is r cos beta minus alpha, This quantity is Fc. Fs equal to Fc cos phi minus this quantity is r sin beta minus alpha is Ft sin phi. If cutting force, thrust force and shear angle are known, then we can calculate the shear force. Now take Ns equal to r sin phi plus beta minus alpha. As we know, sin A plus B equal to sin A cos B plus cos A sin B. R sin phi cos beta minus alpha plus r cos phi sin beta minus alpha. R cos beta minus alpha sin phi plus r sin beta minus alpha cos phi. Ns equal to Fc sin phi plus Ft cos phi. Friction force F equal to r sin beta equal to r sin, we can also write alpha plus beta minus alpha. Alpha is added and then subtracted. We can apply sin A plus B, means sin alpha cos beta minus alpha plus cos alpha and sin beta minus alpha. F equal to r cos beta minus alpha equal to Fc sin alpha plus r sin beta minus alpha is Ft cos alpha. Fc cos alpha. Similarly, n equal to r cos beta equal to r cos alpha plus beta minus alpha. We can apply cos A plus B that is cos A cos B minus sin A sin B, r cos alpha cos beta minus alpha minus sin alpha sin beta minus alpha, and will be fc cos beta as r cos beta minus alpha equal to fc, and ft sin alpha r sin beta minus alpha equal to ft. As we know, the friction coefficient of friction is mu will be equal to tan beta, that is equal to f upon n. F equal to fc sin alpha plus ft cos alpha upon fc cos alpha minus ft sin alpha. Divide by cos alpha, fc, if we divide by cos alpha, this will be tan alpha plus this will be ft upon this is fc and this is ft tan alpha. So coefficient of friction mu will be equal to ft plus fc tan alpha upon fc minus ft tan alpha. Look at this diagram: tool, workpiece, chip, and small t. Small t is the uncut chip thickness. Small t is uncut chip thickness. Phi is a shear angle. AB is shear plane. AB is shear plane. Sin phi will be, this is phi, sin phi will be small t upon AB. So AB will be t upon sin phi. AB equal to t upon sin phi. Tau is mean shear stress. Mean shear stress is equal to shear force upon shear area. AS is the shear area. Shear area will be AB multiplied by B. AB is the shear plane, B is the width of chip. Width of chip. So Fs equal to tau AB and B. If we put the value of AB, Fs will be tau AB equal to t upon sin phi, t B upon sin phi. Fs shear force will be equal to tau. Tau is the main shear stress, t is the uncut chip thickness, B is the width of chip, and phi is the shear angle. The Fs equal to tau t B upon sin phi. Sigma is normal stress. That is equal to ns upon shear area. ns will be sigma multiplied by shear area equal to sigma AB multiplied by small b. So if we put the value of AB, sigma TB upon sin phi, ns equal to sigma TB upon sin phi. Divide equation 1 by equation 3. Fc by Fs will be R cos beta minus alpha upon R cos phi plus beta minus alpha equal to cos beta minus alpha upon cos phi plus beta minus alpha. Fc equal to Fs cos beta minus alpha upon cos phi plus beta minus alpha. We put the value of Fs from equation C1. Fs equal to tau Tb upon sin phi, and we will get tau Tb cos beta minus alpha upon sin phi and cos phi plus beta minus alpha. And in order to determine the shear angle, we will differentiate cutting force by shear angle and equal to 0. Minimum energy principle is applied. Minimum energy principle. Minimum energy principle is applied. D upon d phi tau Tb cos beta minus alpha upon sin phi cos phi plus beta minus alpha equal to 0, or d upon tau Tb cos beta minus alpha, this is constant, d upon d phi equal to 1 upon sin phi cos phi plus beta minus alpha equal to 0. When we solve this differentiation, we will get tau Tb cos beta minus alpha cos 2 phi plus beta minus alpha upon sin square phi and cos square phi plus beta minus alpha minus equal to 0. Look at this video how this differentiation is solved. Okay, let's differentiate this. Let's assume t equal to sin phi cos phi plus beta minus alpha. dt upon d phi will be sin phi cos phi plus beta minus alpha plus sin phi and sin phi plus beta minus alpha. This will be minus sin phi plus beta minus alpha. So this will become cos phi plus beta minus alpha minus sin phi plus beta minus alpha, and this will become cos A cos B minus sin A sin B, means cos A plus B, cos phi plus beta minus alpha. dt upon d phi will be cos 2 phi plus beta minus alpha. 1 upon d phi 1 upon sin phi cos phi plus beta minus alpha equal to d upon dt 1 upon t dt upon d phi, and d upon dt upon d phi equal to minus t dt upon d phi equal to 1 upon minus 1 upon t square dt upon d phi. Put the value of t and dt upon d phi, we will get minus cos 2 phi plus beta minus alpha upon sin phi cos sin square phi cos square phi plus beta minus alpha. So we can this when we put this value into this equation, we will get minus tau t b cos beta minus alpha cos 2 phi plus beta minus alpha upon sin square phi and cos square phi plus beta minus alpha equal to 0. Okay, now we have tau t b cos beta minus alpha cos 2 phi plus beta minus alpha upon sin square phi cos square phi plus beta minus alpha equal to 0, or we can write cos 2 phi plus beta minus alpha equal to 0 equal to cos 90 degree 2 phi plus beta minus alpha equal to 90 degree pi by 2. 2 pi plus beta minus alpha equal to pi by 2, or phi equal to pi by 4 minus 1 by 2 beta minus alpha. So we can calculate shear angle if we know friction angle and rake angle.